The McAdam Shield Shovel. Weird tech. World War I. The McAdam Shield Shovel, or Hughes Shovel, was a two-in-one solution designed for the trenches of World War I by a Canadian named Sam Hughes, who was the Minister for the Department of Militia and Defense in 1913. The device would resemble a standard infantry shovel with a hole in it, so that it could also act as a sniper's shield. The shovel would be named after Ina McAdam, Hughes's personal secretary, who suggested the idea in 1913 when she saw Swiss troops digging trenches and suggested that they could combine their entrenching tools with bulletproof shields. To use it as a shield, the soldier would lie in prone with the rifle placed through the hole, with the shovel handle rotated 90 degrees to expose the spike that drove into the ground. In 1914, 25,000 shield shovels were produced for the Canadian Army. Hughes proclaimed them a Canadian miracle device, but after field testing, it was clear that the expensive piece of equipment had many problems. It was heavy because of the thick steel necessary to deflect a bullet, and difficult to carry as it had no carrying handle. Even worse, the shield shovel couldn't actually deflect bullets, even if they were small in caliber, and was not good for digging because of the hole in the blade. High-ranking Canadian and British military officials, including Arthur Currie, refused to accept the shield shovel. It was stated by Saturday Night magazine that the McAdam shield shovel was only good for one thing: opening tins. The shovels were soon replaced by British entrenching tools and turned into scrap metal, although some Canadian snipers did make use of the device, placing many together for effective protection.
The Calibri Mini Pistol. The Calibri is the smallest commercially available center-fire cartridge semi-automatic pistol made in history. The Calibri was designed by an Austrian watchmaker named Franz Fanel and financed by Georg Grabner. Patented in 1910, it was produced around 1914 before the outbreak of World War I. Its name, Calibri, is German for hummingbird, which is one of the smallest birds. While it appeared as a novelty, it was marketed as a ladies' self-defense weapon against criminals that was compact enough to fit in a handbag. The Calibri had an overall length of 2.8 inches or 7 centimeters and had a blowback action like a normal pistol. Due to its scale and manufacturing technology of the time, it lacked rifling, making it very inaccurate. The magazine would carry 6 rounds, which was difficult to load. The caliber was just 2.7 millimeters, and its cartridge weighed just 5.3 grams or 82 grains. A 3mm version of the Calibri was also made later on, which used a lead bullet instead of a jacketed bullet like the 2.7mm caliber. The pistol had a muzzle velocity of around 200 meters per second or 656.2 feet per second, and a muzzle energy of just 4 joules or 3 foot-pounds. Its recoil was non-existent. Questionable beyond killing rodents, the bullets were weaker than a pellet gun and would even bounce off a woolen coat. But perhaps it could have done some harm if shot at a criminal's face in self-defense. 1,000 of these pistols were produced from 1914, with production interrupted at the outbreak of the war, and production of larger 3mm and 4mm versions continuing until 1938. Most Calibri pistols were lost, destroyed, or taken by foreign soldiers as souvenirs in Central Europe during the 2 World Wars.
Sniper Decoys. Dummy Head. World War I. The First World War saw extensive use of snipers in combat. For the first time, rifles with telescopic sights were used on a large scale, which under the conditions of trench warfare were considered very effective. At first, the German Imperial Army were the only ones to seriously consider scoped rifles. As soon as the British and French were aware of the German successes with scoped rifles, they also introduced them to the battlefield. Even though sharpshooters existed before, it was the introduction of scopes that allowed them to shoot accurately at very long distances. With a scoped rifle, a good marksman was able to acquire his target very easily. He could kill an enemy that barely protruded his head over the trench parapet if he was fast enough. With such horrifying capabilities, snipers became an object of fear for the soldiers in the trenches, especially because they fired from well-concealed positions. Since the art of camouflaging was developing more and more as the war progressed, snipers became harder to detect. For soldiers whose everyday life was weighted by the threat of snipers, it became a necessity to counter this danger. With the awareness of the sniper threat widespread, soldiers paid a lot of attention not to expose themselves. This forced snipers to act quickly and to use the shortest moment to fire at the enemy. It was based on this hastiness that camouflage units designed their deception. Their intention was to force the enemy sniper into making a flawed decision and to draw out his fire so his position could be located. One of the most popular decoys of the war were papier-mâché heads. Papier-mâché was a very popular material before the war and was used in making dolls and various components for amusement parks, carnivals, and expositions. It was very cheap, but to make it consisted of chopping down pieces of paper, reinforced with any kind of bounding material, whether it was glue or plain starch. Besides the fact that it was cheap, it was also very good for modeling. The job of making decoy heads out of papier-mâché was entrusted to camouflage units, who were working in their small improvised workshops on the front lines. Sculptors working in these workshops made a huge variety of decoy heads with great precision and resemblance to real human heads. Special attention was given to shaping face details and coloring the face to look like real skin. This push for realism was necessary because they were to be observed through scopes with magnifying lenses. In order to increase the realistic look of the head, some of these were equipped with rubber surgical tubes connected to the mouth with a cigarette in it. By blowing air through the tube, an impression of a soldier smoking a cigarette was made. This increased the possibility of attracting the attention of the sniper. Papier-mâché heads were usually stuck on a long stick in order to securely lift it over the parapet. If the deception was successful and the dummy head was hit by a sniper, bullet holes were then used to locate the sniper with the help of a triangulation method. Or another method was to slide a periscope into the head and spot the sniper that way. Once the approximate location was established, the sniper's position was bombarded by artillery or counter-snipers would focus on that area. The technique of dummy heads was invented by the British, who at the beginning of the war had a lot of problems with German snipers. This method was a result of their struggle to fight the hidden enemy. The same method would also be used by other sides. Dummy tanks. Weird tech. World War II. Dummy tanks were constructed in World War II as a deception tactic to mislead the enemy on the real strength of the Allied forces or the real location of upcoming attacks. Although they were sometimes used for training purposes, dummy tanks were often used for real operations. The first dummy tanks in World War II were built by the 8th Army Engineers and were used in North African campaigns before the Battle of El Alamein to deceive Rommel about the strength and the movements of the 7th Armored Division. These tanks were made of wood and were easy to disassemble for the purpose of mobility. Engineers went even further by putting wooden tank constructions on top of cars and jeeps in order to create the illusion of movement. The use of dummy tanks would be used on a greater scale during the Normandy landing preparations as part of Operation Fortitude, a deception that was set to mislead the Germans into thinking that the landing would take place in Pas-de-Calais instead of Normandy. In order to confuse the Germans, an entire dummy army named the 1st United States Army Group was created that was supposed to resemble General George S. Patton's forces. This time, the Allies were using inflatable tank models as they were easier to build and transport. Dummy tanks were being made on the skeleton of inflatable rubber tubes, which were then covered by rubberized canvas. These kinds of models were easy to make and had less chance of being deflated if hit by shrapnel. The mobility of rubber tanks was excellent, as dummy M4 Shermans weighed only 93 pounds or 42 kilograms when fully inflated. Dummy tanks would be inflated in the middle of the night and could spring up just about anywhere. Once inflated and put in position, dummy tanks were poorly camouflaged in order to be visible for German reconnaissance planes. To make the impression more complete, dummy tanks were followed by real tanks and bulldozers in order to make traces of tracks. Double agents also helped spread false information in order to make the deception more convincing. The success of this fake army helped contribute somewhat to the Germans believing that the Allied invasion would take place at Pas-de-Calais. However, by this time in the war, it was difficult for enemy reconnaissance planes to reach England, and the double agents who were effective at spreading false information to the Germans were the biggest reason for the success of Operation Fortitude. As a result of the overall deception, the German reserves were kept at Pas-de-Calais in anticipation and away from Normandy, where they could have reinforced its defenders. It was so effective that they remained in the region weeks after the real invasion, thinking there would be a second, larger invasion. After D-Day, the Allies continued to use inflatable dummy tanks to deceive the enemy. The task of deception was given to a newly formed unit known as the Ghost Army, who took the illusion to the next level. Dummy tanks were used along with tank sounds emitted from large speakers, enhancing the deception of a real armored unit. The Ghost Army was successful in staging around 20 enemy deceptions after the Normandy landings. Fake trees, weird tech, World War I. During the First World War, engineers were constructing new ways of concealment, with some creative results. One such form of camouflage were fake trees that were used as observation posts or as sniper nests. The first fake tree was invented by French painter Lucien Victor Guérin d'Esquevola and his camoufleur artists employed at the Section de Camouflage of the French Army. They made an iron lookout post and camouflaged it with tree bark and other natural materials. They would deploy their first artificial tree during the Second Battle of Artois in May and in June 1915. These fake trees were used to spot German positions for artillery and correct its fire. However, preparation of such trees on the front line was a very dangerous job, and 15 camoufleurs were killed while installing them. Since it proved to be a successful way of observing the enemy, fake trees attracted the attention of the British, who sent a painter named Solomon Joseph Solomon to learn the trade from their French allies. Solomon quickly understood the principle of fake trees and took it to a higher level. Solomon wanted to create and conceal artificial trees in a manner that copied actual trees on the front line. For that, he used engineers who picked a real tree on no man's land, preferably a dead one blasted by an explosion, and then made a detailed sketch of it. Working with famous British sculptor Leon Underwood, Solomon created his first OP tree, or observation post tree. It was made of steel cylinder sections wide enough for one soldier. Inside the 10 to 15 foot tall tube were ladders that led to a seat on top for the soldier who would observe the enemy through special slits. The soldier inside the tree was in constant connection with his commanding officer. To make them properly concealed, Solomon decided to cover OP trees with natural barks. For that task, he picked willow barks from King George's estate at Windsor Castle. The reason why Solomon addressed King George was that he believed that discretion with the king would be guaranteed. Although the construction of the tree was a difficult task, installing it was even harder. Installation had to be done during the night and finished by next morning, so the enemy wouldn't notice the change. Engineers would cut down the real tree and dig out a hole where the roots were. Then the fake tree would be positioned in place and everything would appear the same in the morning. Ideally, the tree would be installed amongst a series of real trees in order to be more difficult for the enemy to realize the deception. Once installed, fake trees provided a great observation of the enemy trenches and were also good firing positions for snipers. The Germans were also aware of the idea of fake trees. Their Bombeobachter, or tree observer, was built in the same manner as the British version and was equally as good. One such creation was 25 feet tall and built at the trenches of the Oost-Auvergne Wood during the Battle of Messines in Belgium. Their artificial tree was designed so well that British soldiers didn't discover it for several months even after they had captured the German lines where they were placed. What was the thing? The Cold War. On August 4, 1945, a group of Russian schoolchildren from the Vladimir Lenin All-Union Pioneer Organization presented a 2-foot wooden replica of the Great Seal of the United States to the U.S. ambassador to the Soviet Union, Avril Harriman. Believing it to be a mere friendly gesture of friendship between the USSR and the USA as allies in World War II, the Great Seal was hung up proudly on the wall of the ambassador's residential study in the library at the Residency Spaso House in Moscow. What the Americans didn't know was that this gift was holding a secret. This gift was not merely decorative. The Soviets had placed a high-frequency radio bug inside. This listening device, dubbed the Thing, enabled the Soviets to eavesdrop on confidential conversations of the U.S. ambassador. Surprisingly, The bug worked without batteries or electrical circuits. Instead, it was initiated when a radio signal aimed at its antenna from a van parked outside the building activated it. The sound waves from conversations within the office caused vibrations of the membrane inside the carving of the Great Seal, which beamed back to the surveillance van. This simplicity meant that the listening device had an almost unlimited lifespan and was difficult to detect. The thing was on display for 7 years until it was discovered in 1952. In 1951, a British radio operator suddenly picked up a signal, accidentally overhearing American conversations while the Soviets were using the bug. The sweep didn't find anything. In fact, whenever major repairs were made to the offices, the walls were inspected for any concealment of bugs. The Great Seal was always taken away and examined, and then returned in place afterwards. A second sweep in 1952, provoked by another accidental overhearing of the ambassador's office on a radio signal, found the bug in the Great Seal. At first, the Americans were confused by the seal and didn't know if it was an actual bug because of its simplicity. But eventually, after analysis, it would lead on to a British version of the device. The discovery of the bug was kept a secret by the Americans until the U-2 incident in 1960, when the Soviets accused the Americans of spying. To show that both sides were guilty of this, the Great Seal bug was revealed during the meeting by U.S. Ambassador Henry Cabot Lodge, Jr. The Krummlauf, curved barrel. In 1943, Germany started researching and developing the Krummlauf, or in English, curved barrel. It was an odd-looking device designed to fill requests from German tank crews so that they could more effectively engage Soviet troops as they climbed onto their vehicles and attacked the blind spots of their existing machine guns. Early on during testing, the German military realized that the concept would also be beneficial to infantry in trenches or in urban combat. The gadget could allow the soldier to shoot at angles without exposing his head, such as around a corner of a building. At first, the Krummlauf was only designed for Germany's service rifle, the Kar 98K. After the adoption of the MP-43, later called the Sturmgewehr 44, all testing was centered around the new weapon and its new caliber, the 8mm Kurz. The result of much testing was the two optimal degree angles for the curved barrel, 30 degrees and 90 degrees. The 30-degree barrel, named the Vorsatz J, was intended for infantry use and had a periscope mounted on the barrel for aiming, while the 90-degree barrel, or the Vorsatz P, was developed for vehicle use and was intended to be used in a ball mount so that the vehicle crew would not have to expose themselves. This design was not flawless. Barrels were prone to warp or explode under continual use and pressure, and the bullets tended to break up on the curve, which would give it a shotgun-like effect in some cases. The Krummlauf was issued too late in the war to see much combat or make much of a difference in any battle. After the war, both the American and Soviet militaries experimented with the design. During the Korean War, American tank crews encountered the same issues as the German crews many years before. As a result, the U.S. Army developed an M3 grease gun with a curved barrel for tank crews to defend against inbound Korean and Chinese infantry. The Soviets seemed even more interested in the design and developed many firearms with curved barrels. Early developments were based around the PPSH-41, while later designs were based around the SG-43, RPD, and even the AK-47. The drip rifle, World War I. During the evacuation of Gallipoli by the Allies, which started in December 1915, an ingenious invention was constructed on the battlefield by Anzac forces to deceive the Ottoman enemy into thinking a large force was still firing back at them, when in reality, the rifles were shooting without a person pulling the trigger. This invention, which was called the drip rifle, or pop-off rifle, was developed by an Australian called Lance Corporal William Scurry, who was assisted by his friend Bunty Lawrence. It worked by using two ration tin cans, one filled with water with a hole punched in it, and the other empty and attached to the rifle's trigger using string. The rifle was loaded and fixed in position with sandbags. Over time, the water would drip out of the first tin can, filling the lower can until it had reached a certain weight, pulling the trigger and firing the weapon. By this time, the soldiers were long gone, but from a distance, it would give the impression that the position was still manned. The variation in methods and weight would also make the shots appear at random times and intervals. This deception was put to the test alongside mannequins and dummy artillery pieces on the last night of the evacuation from Gallipoli. Scurry and Lawrence rigged the drip rifles along random points of the Anzac firing line. The last 2,000 men who made up the Allied rearguard then quietly withdrew, deceiving the Ottoman enemy into thinking that they were still there. The rearguard would evacuate successfully without any casualties. Scurry was later awarded the Distinguished Conduct Medal in recognition for his invention. Periscope Rifles, Weird Tech, World War I. For the soldiers stuck in the stalemate of World War I, fighting from the trenches was no easy task. Shooting from the trenches meant that a soldier had to stand up over the parapet, exposing his head in order to aim at the enemy, posing a perfect target for enemy snipers. Therefore, soldiers needed to find a way to shoot the enemy without the risk of being exposed and shot. The invention of the periscope rifle would allow them to avoid that risk. Although it appeared on the Western Front first, the invention of the periscope rifle can't be credited to just one individual. The necessity to stay concealed while shooting led to almost simultaneous occurrences of periscope rifles on the battlefields across Europe. Some were made in specialized workshops, and some were improvised by soldiers on the battlefield. The first patent for a periscope rifle attachment was by William Youlton from Great Britain. He applied for the patent in the first days of the war in 1914. His device, named the hyposcope, was a rifle butt sighting attachment. It consisted of one double reflecting prism that was mounted over the butt. The prism allowed the shooter to aim while staying below the line of sight. The hyposcope was designed to be attached on British Lee Enfield rifles, but was used with other rifles and even machine guns as well. Without knowledge of Youlton's invention, an Australian, Lance Corporal William Beach, invented his version of the periscope rifle in May 1915, in the trenches of Gallipoli. Beach got the idea after witnessing his fellow soldiers being shot in the head while trying to shoot the Turks above the trenches. Being a construction foreman, he worked to attach a periscope to a rifle. His device was a wooden frame for the Lee Enfield rifle, with a box periscope. The upper mirror of the periscope was in line with the rifle's sights, and the lower mirror aligned to the soldier's eyes. The shot was fired via a wire that was connected to the rifle's trigger. With this device, a soldier could shoot his rifle from the top of the parapet while standing safely below it. The accuracy of the periscope rifle was relative and depended on the skillfulness of the shooter. However, as the distance between the opposing trenches on the Gallipoli battlefield was pretty small, the periscope rifle proved to be effective. The drawback of the device was that the bolt was out of the reach of the shooter, who had to take the rifle back down to cycle it after each shot. As Beach's periscope rifle proved its worth, he was ordered to establish a workshop on the beaches behind the front lines, where he made more periscope rifles. The Turks eventually captured and copied their own versions later on. Another British periscope rifle was one constructed by J.E. Chandler. The device he made in September 1915 was more complex, but more efficient than previous inventions, as it had levers for actuating the bolt. This rifle allowed the shooter to fire all 10 rounds from the rifle without having to bring it down each time. Periscope rifles were also used by the German army. Among their many field improvisations, the Germans also produced factory-made periscope attachments. Their periscope rifle attachment, the Spiegelkolben, was quite simple in its design, but it was very effective. Its entire frame contained the periscope and was made of steel with a buttstock of its own, which resulted in better accuracy. To fire, the soldier pulled the auxiliary trigger, which was attached to the rifle's trigger by a chain. Some versions had a mechanism to cycle the bolt without bringing the rifle down after each shot. Another improvement allowed the soldier to adjust the periscope height. The German periscope rifle also had an extended 25-round magazine and luminous sights for shooting at night. The most advanced periscope rifles were made in the United States. One such device was made by J.L. Cameron and Lawrence E. Yagi from Cleveland, Ohio. Their device was a steel frame designed for the Springfield Model 1903 rifle with a magnifying periscope, trigger extension, and bolt-action lever. In addition, there was a 25-round extended magazine. Another American design was made by Mr. Giberson from California. At first glance, Giberson's model looked like a standard Springfield M1903 rifle. However, the press of a button opened a collapsible hinged stock with a built-in periscope, turning the ordinary rifle into a periscope rifle. This design was definitely the most advanced version and had great mobility, but it seems it was made too late to see action on the battlefield. Periscope rifles were primarily used by standard infantrymen, while marksmen preferred the standard sniper rifles and hidden nests. Although periscope rifles did provide safe shooting from cover, they were quite inaccurate. As the weapon was being used from below while laid on sandbags instead of being held firmly in a soldier's hands, periscope rifles were very unstable and the recoil was much greater. For a sniper, such a device couldn't compare with having the rifle firmly in his shoulder. Furthermore, aiming through the periscope wasn't an easy task, especially if the mirrors became smeared, which was frequently the case in the muddy trenches. Also, if a mirror was shot out of the periscope by an enemy sniper, any form of replacement mirror had to be found, including shaving mirrors. With a periscope rifle, even a good shooter had the problem of hitting the target at distances further than 100 yards. Tank gun suppressor. Located near the town of Meppen in Lower Saxony, Germany, is one of the largest weapon testing sites in Europe, Wehrtechnische Dienststelle 91, or the WTD 91. Its total area is 19,200 hectares, and it's 19 miles long and 3 to 4 miles wide. Equipped with high-tech measuring devices, the WTD-91 is the leading testing site of the German Bundeswehr, where extensive testing of tanks and self-propelled howitzers are conducted. The test site may be the pride of the German military, but at times it's been a burden for the citizens of nearby Meppen. The 120mm gun of the Leopard 2 tank produced noise of almost 80 decibels at a distance of 1 mile, or 1.6 kilometers behind the gun muzzle. For civilians living on the edge of town less than a mile away, it was a huge disturbance. Noise of 80 decibels is equal to the sound produced by heavy traffic or a passing freight train. After prolonged exposure to this noise level, people are more susceptible to permanent hearing loss. Needless to say, the personnel working on the test site suffered even greater stress caused by the gun blasts. At distances of 800 feet or 250 meters, the gun produced a noise of 115 decibels, which is above the average human pain threshold. In order to meet the citizens' demands for a peaceful and quiet life and improve the working conditions of the WTD-91 employees, the German Institute for Noise Protection, in cooperation with renowned arms manufacturer Rheinmetall and MAN, devised an interesting solution: a gun muffler. The muffler was originally designed for the 120mm gun of the Leopard 2 tank. It was intended to be used on shooting ranges with static firing positions. After conducting a thorough study, experts from the Institute found a solution by building a large muffler drum fitted with V-shaped barriers for capturing the propellant gases once the projectile was fired. The muffler drum would trap the gases and release them in 2 smaller blasts, followed by a steady subsonic flow of residue. This procedure worked in preventing a deafening sonic boom, therefore resulting in a significant reduction in noise. With the muffler mounted, the noise produced by a Leopard tank at a distance of 1 mile was reduced from 80 decibels to 60 decibels, the sound level of a normal conversation. Because the construction was too heavy and cumbersome, it was impossible to mount the muffler directly to the tank's gun barrel. The only solution was to mount it on a steel carrier structure and use it from a static firing position. After all, the muffler was designed to be used in ranges close to urban areas, not in combat. With the tank gun muffler confirmed as a successful solution, a modified version was made for self-propelled howitzers. The howitzer muffler was made by attaching an extra module to the tank muffler. The upgrade was fitted with side tanks positioned to capture the gases flowing horizontally from the muzzle brake, such as on the M109G 155mm self-propelled howitzer used by the German Bundeswehr. The howitzer muffler was mounted on an adapted steel carrier structure at a 30-degree elevation. The German gun muffler was not the first such design. In the late 1960s, the United States Army went through a series of tests with what was called an experimental silencer for the 105mm gun of the M60 tank. The silencer was a large steel tube mounted on a wheel carriage. It was 40 feet or 12 meters long and 5 feet or 1.5 meters in diameter. Instead of baffled chambers, it contained plastic bags filled with water to capture the propellant gases. Another design appeared in the 1980s, made by the engineers of the Construction Engineering Research Laboratory of the U.S. Army Corps of Engineers. The patent, designated as a muzzle blast reducing device, was a hollow container filled with liquid foam that could be attached to a gun muzzle. Neither of these designs ever materialized or were put into service. The German gun muffler therefore remains the only one of its kind. Despite its quite odd appearance, it serves the purpose of reducing the blast noise of large guns.
The Bazooka Vespa. The Vespa 150 TAP. The Vespa 150 TAP, which stands for Truppe Aeroportate, or Air Troops Carrier, was an anti-tank scooter slightly modified from the body of a standard Vespa 150cc scooter. The 150 TAP was manufactured by the Vespa French licensee ACMA at the request of the French Ministry of Defense in order to create a small, portable anti-tank system that was intended for use by French paratroopers. These new military Vespas were intended for use in Indochina and the conflicts in Algeria by the Truppe Aeroportate, also known as TAP, hence the name of the model. The TAP was designed to be dropped in with French paratroopers in order to give them the firepower of a full-scale howitzer, but with much higher mobility. The Vespa 150 itself was a small two-person scooter that began production in 1955. The TAP was a version of the 150 that had an M20 75mm recoilless rifle attached to the side of the scooter. Weighing in at 253.5 pounds or 115 kilos, the Vespa 150 TAP had a top speed of 41 miles per hour or 66 kilometers an hour and a fuel range of 124 miles or 200 kilometers. It therefore made the TAP a maneuverable and quick weapon highly suited to guerrilla tactics, airborne troops, or simply when tanks and artillery support could not be used due to poor road conditions or were too far away and could not be called up for support. The Vespa 150 TAP was modified for combat use and included reinforced frames, lowered gear ratios, and had a 146 cubic centimeter single-cylinder two-stroke engine. It was outfitted with 2 fuel cans and 6 rounds of ammunition for the M20. These shells would sit 3 on each side of the rear seat behind the driver and under the legs of the passenger. The M20 recoilless rifle was an American design that came into service in 1945. It was originally designed to be carried by hand by a group of soldiers. The weapon itself was rather light, only weighing in at 114 pounds when attached to its tripod, making it much lighter than any other artillery piece in the world at the time of its invention. Because of its low weight and devastating 75mm round, the M20 was a perfect companion to the lightweight and nimble Vespa scooter. While it was indeed attached to the Vespa, the M20 was not designed to be fired from the vehicle. Instead, the weapon was designed to be removed from the Vespa, placed on a tripod, and then fired by a team of 2 men. Although theoretically it was possible that the weapon could be fired from the scooter and while it was moving. Due to the large 75mm round that the M20 fired, it could penetrate the armor of most tanks and could easily destroy earthworks and pillboxes with a direct hit. It could engage enemies at ranges of 7,000 yards or 6,401 meters. The TAP was produced over a period of 3 years, from 1956 to 1959. In that time period, roughly 600 Vespa 150 TAPs were produced in France. The vehicle was produced in both green camouflage and desert camouflage patterns, in accordance with French conflicts in both Asia and Africa throughout the 1950s and into the early 1960s, where the French were facing rebel insurgencies. They were used to combat the enemy's light, fast-moving counter-guerrilla tactics, making it the perfect vehicle in providing highly portable yet hard-hitting artillery. Air crews dropped the Vespas into hot zones 2 at a time, accompanied by a pair of paratroopers. One scooter carried the gun, while the other carried the rounds. Little is known about how popular the TAP was with French paratroopers or how well it performed as a military artillery platform, but based on the low production numbers and what was only a 3-year production run, it is safe to say that the French military quickly moved on from the idea of scooter portable artillery.
Mobile shields. World War I. Weird tech. World War I was the war of innovations and new types of weapons and equipment. A lot of effort was made to protect the soldiers both in the trenches and in no man's land. One way to do it was with the help of infantry shields. Sniper shields were a kind of small metal shield that served to protect snipers from enemy fire. These were good as protection if he was well concealed, but were far too heavy to be used when advancing. For that reason, mobile shields were introduced to be carried by soldiers into battle. These shields were initially quite small, and therefore only provided minimal protection to the soldiers. They only really protected the soldier's torso, leaving his limbs exposed to a risk of injury. There was a tendency to make big, strong, and heavy shields that could protect a soldier's entire body. It also had to be able to be moved around the battlefield. The only solution was to put wheels on them. These were to be known as mobile shields. Their purpose was to provide cover to one or several soldiers that were advancing across the field or no man's land. The idea of shields on wheels was actually born a few decades earlier during the Cuban War, when U.S. troops used the first movable shields. The idea was adopted by the British and French armies and brought into service during World War I. Even though all designs included heavy steel plates that were capable of withstanding small arms fire, their use was questionable in reality. The first mobile shield was created by the French. It was quite a simple design that consisted of a heavy steel gun shield mounted on two large hollow wooden wheels. The wheels were filled with sand to give them some weight and make them stable while moving. The front plate had a slot with a movable shutter. Looking through the slot, a soldier was able to see the direction in which he was crawling, but was also able to aim and fire his rifle. The French introduced the shield in 1917, and by the end of the war had made a considerable number of them. They were mostly used for cutting through barbed wire. Hidden behind the shield, the soldier was protected from enemy fire while crawling towards his objective. The British one-man tank was a bit more complex. This mobile shield was made completely out of metal, including the wheels. The hull was made of chrome nickel steel and covered almost the entire body of the soldier up to his thighs. The inside of the hull was fitted with grips for the soldier to hold so he could handle the shield. In order to move it, the soldier had to crawl on his knees, which was a very uncomfortable position. On the bottom side, it had two hinged skirts that provided side protection while moving about on uneven terrain. Unlike the French design, the one-man tank had two horizontal and two vertical slits on both sides of the plate that served as viewports. On the left side, there was an additional slot for aiming and firing a rifle. This had a shutter to close when it was not required. The front plate had an angular shape in order to deflect small arms fire. The French version had a large hook mounted on the front plate so that it could be towed into position if necessary. The British designed another two mobile shields during the war. Both were of a much larger and heavier construction than the one-man tank. The first one was a larger scale version of the French design and was big enough to provide cover for 5 soldiers. It had 5 embrasures on the front plate, 3 on the top part and 2 on the bottom part of the plate. It was very cumbersome and difficult to move, and it never went beyond the trial stage of its development. The second large mobile shield was really huge. It was called the pedrail. It was a platform for a machine gun with a large, thick front plate and 2 hinged side plates. Both side plates had 4 slots for the rifleman. The front shield was 5 feet 11 inches wide, or 1.8 meters, and 4 feet 11 inches, or 1.5 meters tall. With the side plates fully open, the shield had a width of 9 feet 10 inches, or 3 meters. With a machine gun mounted, it weighed 3,000 pounds, or 1,360 kilograms, making it very difficult to move around. It seemed that both these shields were designed for static rolls only, probably as road or street barricades. Mobile shields featured on the Eastern Front as well. A German photo from 1914 shows the Russians had mobile shields of their own. It is unknown whether they produced them on a larger scale or not, but it's obvious that they were aware of the concept. The Russian mobile shield was also huge. It was wide enough to protect 5 soldiers standing and another 5 in a prone position. Therefore, it had 10 slots set in 2 rows on the sloped front plate. On the side, the shield had 2 large diameter wheels and 4 small auxiliary wheels behind the plate. The construction was so bulky that it needed a lot of manpower to be moved around. Basically, the mobile shield was just too bulky and unwieldy to be of any use. They were very big, very heavy, and therefore very slow out in the field, and unable to keep up with the advancing infantry. The sluggishness, however, seemed to be a minor problem regarding their mobility. The whole construction of mobile shields was too crude to be able to move around on the moon-like craters of the terrain of the World War I battlefields. Heavy metal wheels had no suspension, which made a terrain filled with shell holes impassable, even to the smallest mobile shields. Finally, all mobile shields were designed to protect a soldier from small arms fire being directed in front of him, except for the British one-man tank, which also protected the sides. Since they had no other protection, soldiers behind the shield were completely vulnerable to shrapnel coming from shells exploding around and above them. Because of the poor protection that they offered and their lack of maneuverability, mobile shields became perfect targets for the artillery, which was the most destructive weapon on the battlefield. These disadvantages questioned justifying the use of the shield and were probably the reasons why they were not used on a larger scale. In any case, mobile shields stand as another curious weapon of World War I.